Here's pre-cap. This is problem 8-137, and it says if cosine of x is negative 4 over 5 and sine of x is negative, then calculate the values of sine 2x, cosine 2x, sine x over 2, and cosine x over 2. So, and then it also says first draw a triangle in a unit circle and calculate the values of the missing sides, and then determine if the value of the function you are using in the identities is positive or negative based on the angle, or on the location of the angle. So I went ahead, I shouldn't have probably calculated the angle, I got a little silly there, but I know to draw, I know that quadrant 1 everything's positive, quadrant 2 only sine's positive, quadrant 3 only tangent is positive, and quadrant 4 only cosine's positive, and we have a little acronym, all students take calculus. So don't get that confused with never eat soggy waffles. So I know that my cosine is negative and my sine is negative, so I know that my triangle has to be in quadrant 3. I know that I know my SOHCAHTOAs. So cosine is adjacent over hypotenuse, so the 4 must be the adjacent and the 5 must be the hypotenuse. I could have made this into like a unit circle, and this could have been 4/5 and 3/5 and 1, but it's kind of like I blew up my unit circle and so that I don't have to deal with fractions. So anyway, we know it's, and how did I get the numbers? It's a 3, 4, 5 Pythagorean triple. If I wouldn't have known the 3, I would have gone 3 squared plus b squared equals 5 squared. And that's how I got that. And so now I'm going to go ahead and try to identify whether these angles are going to be positive or negative depending on what quadrant they're in. So the original angle's in quadrant 3, and I don't know why I felt like finding out what it was, but I did inverse, I did cosine inverse just to find out that it was 36 degrees plus 180, because we know it's right here. I don't know why I did that, but maybe that'll help you to understand that the half angle would be half of this angle. So that's going to land, it's 108, so it's going to land in quadrant 2. And the double of it would actually be all the way around. It ended up being 433 degrees. So I subtracted 360 from it to find that it's in quadrant 1. So now I know that all my half angles are in quadrant 2. Let's look at the half angles. So sine in quadrant 2, is sine positive or negative in quadrant 2? It's positive, so the sine's going to be positive, but then of the half angle, because remember the half angle is in quadrant 2. Cosine's negative in quadrant 2, so this is going to be our only answer that's negative, because it turns out the double angle ones, the double angles, those are in quadrant 1. Everything's positive in quadrant 1, so these are all positive. So now that we have that all taken care of, I'm going to erase these negative thingies on here, because I'm not going to deal with negatives now, because all I needed that for was to know which quadrants things are in. So now I'm just going to go ahead and find out what sine of 2x is. I have a formula, because I can find out what sine of x, sine is just opposite of, oh, oops, you can't see. Sine is opposite over hypotenuse, so sine would just be 3 over 5, right? Cosine would be 4 over 5. I don't have to do any, or if I had to do something with tangent, it would be 3 over 4, opposite over adjacent. So, so sine of 2x, I have a little formula in my magic book somewhere. It's right here. So it's 2 sine x cosine x. So So it's going to be 2 times sine x times cosine x. What is sine x? I just said it a second ago. It was opposite over hypotenuse. It's 3. It's going to be 3/5. And then adjacent over hypotenuse for cosine. So that would be, I guess I could just multiply right across the top. 2 times 3 is 6, times 4 is 24. And then that's over 1, and then over 25. And it's positive. Okay, now I want cosine of 2x. Let me push autofocus. Autofocus. There, that's a lot better. And then cosine of 2x, I can use any of these. I don't know, I guess I'll use the first one. So I need cosine squared or cosine squared x minus sine squared x. So what was cosine again? Cosine is adjacent over hypotenuse. And then opposite over hypotenuse. And so I don't think I have enough room here. So that's 16 over 25 minus 9 25. So I got 7 over 25. I'm just going to write let me do a facts check on that and see if that's correct. Yep, that's correct. Okay, sine x over 2. So now I need to use my formula for sine x over 2. So let me look in my magic book and see if I have it. So it's 1 minus cosine x over, it's the square root of 1 minus cosine x over 2. Wasn't cosine of x, that's adjacent over hypotenuse, so that would be 4/5. Okay, so that's 5/5 minus 4/5 on this top part, so that would be 1/5 divided by 2, which is, I think, 1/10. Let's see, 1/5 divided by 2. It's 1/10. Okay, so I got square root of 1/10. And then if I want to, I can do a bunch of rationalizing on that. I can say it's probably going to be like root. Hold on. I made a little mistake. 137. So, oh, I made a mistake right here. So maybe it's good that I made a mistake. So, the little formula already has a minus sign in it, right? See how it already has a minus sign in it? And the cosine of the original angle is actually negative. So that's actually supposed to be, it would be minus a negative. So that's going to be plus. So that's 5/5. This is actually going to be 9 over 10. Because 1 is 5/5. So 5/5 plus 4/5, that's 9/5 divided by 2, that's 9/10, and then the square root of 9 is 3. So that's going to be 3 over root 10, and then if I rationalize it by multiplying top and bottom by root 10, I'm going to get 3 root 10 over 10. As though you could read the tiny writing. So that's I don't know if that's a common mistake. That's a mistake that I just made. Oh no, we're gonna run out of time. So what I have to do is make another video for the next part.